Later today, I will also post the answer key to the constructed response practice test. So while, yeah, I know you can blindly copy the answers and submit it for that homework grade, you really want to know how to do it because it won't be the exact same on your test tomorrow, but really similar. But for the online one, first one, we have ninth and 10th grade students were surveyed about a new song. They could rate the song from 1 to 10, with 10 being the best. The students' ratings are then placed in two categories: worth listening to for ratings of 6 through 10, and not worth listening to for ratings of 1 through 5. Some of their ratings are summarized below. I won't read the bullet points right now because I'll have to read them again in a second, but they'll give you some information. And you are filling in the two-way table given to summarize the data after it's been placed in these two categories. So first thing I usually check for in the very first paragraph is if they said any other information that's not bullet pointed. So, I mean, all they really told us was like the headings of the two-way table. So they already did that part for you. You just have to now take the given information and put it in the right place and then fill in the rest. So you do have enough information to do that. Table 2, if 24 students were surveyed, where does that 24 need to go in this? Okay, which one? Okay, where both totals cross. It didn't say like there was 24 ninth graders surveyed. It didn't say there was 24 people that said it wasn't worth it, right? They just said 24 were surveyed. So that will always be where the two totals intersect because it's not specific to any of these categories. Okay, so that's accounted for. Table 3, 9 students expressed a rating that was considered worth it. So where does that need to go in the table? So in the worth it row where the total is. Notice that in this bullet point, it didn't say anything about if they were in ninth or 10th grade. So I shouldn't be putting it in those ninth or 10th grade columns because it didn't say that in that one. Table 4, 5 of the 10th graders surveyed gave a rating that was considered not worth it. Where would that go? Like this middle? Okay. All right, and that was 5 of them. So that's 10th grade. They said it was not worth it. That's where they intersect. And then table 5, 14 students surveyed were ninth graders. Where does that need to go? So the ninth grade total right here, 14 of them. All right. And then that's all it gave me. Again, like sometimes they try to trick you and make you think that they didn't give you enough information. So that's why I always say, like, really focus on this paragraph just in case. But there is nothing additional in there that they told us. So now this is what we have. To fill in a blank, you need to have like 2 out of the 3 parts of that row or column filled. Okay, so like I can't fill this in yet because I don't have 2 parts of this or 2 parts of that. So know that. Table 6, what is something that I can fill in based on what I have so far? All right, 10 right here, because we have 2 out of the 3 parts of this row filled, and we know that if this is my total, um, then you have to think what plus 14 gives me 24. Yes? 24 minus 9 will give me this one. What's this one? 15. All right, good. And again, we were able to do that because we had 2 out of the 3 parts of this column. And with every single thing we add in, now we're getting 2 out of the 3 parts of something else, right? So table 1, can you tell me something else I could fill in? Okay, good. And remember, guys, totals are like you adding these parts up. Don't like think of it backwards or something. Don't think that this needs to be 20 because we're adding these together. Like, hopefully, you know, totals would be adding the row or adding the column. But good. Yes, 10 plus 5 is 15. Table 2, what can I fill in either of these? Great. 5 plus 5 is 10. And then now we just have this to fill in class. What will it be? 4. All right. So then 9 minus 5 is 4. 14 minus 10 is 4. It should make sense whatever way you are looking at it. It shouldn't be like these add up and then these do not. Like, it should all make sense in the end. Questions on that one? All right. So any other questions from any other study guide? Massimo? The first one? Okay. So the constructed response, because this one was more conceptual than any other test, like there was fewer calculations than any other test. Know that like when I do check your answers, a lot of them are going to be complete sentences, just so you know. But for number 1, a company makes toys has many different varieties that people can order. The company keeps track of the number of varieties they make and the average sale price for the toys having that variety. They create a scatter plot using the data with the number of toys along the x-axis. So here's your scatter plot. First thing it wants us to do is draw a line of best fit on the provided scatter plot. So you really shouldn't have anything like written under A. It should be written on your given graph. And when you are doing it tomorrow, you'll have like your packet test and you'll have your paper test. I personally would use my other paper to help make the straight line. We know that for it to be considered a line of best fit, we want it to go through the middle of the data where the points seem to be clustered around. So I luckily have a line tool, but you want to make it as straight as possible. So I would line up my paper to see where it looks like it's going through the middle of my data and the points seem to be clustered. I think that's good. That way we kind of have, to me, that looks good. Ours, we're not going to draw our lines the exact same way from each other. But when I do check it, I will be giving you about 5 points if it's in the middle of your points, so the points you can cluster around it. Is it important that it touches every single data point? No. Sometimes there's some that deviate away from our line, and that's fine. So we draw a straight line. So there's that. Then it says write an equation in y equals mx plus b form to represent the line of best fit and show all work. So notice that this one didn't give you a table of values. Okay, so that Desmos thing I told you, the only way you'd be able to try to use Desmos if you forgot how to do it by hand is you have to estimate every single data point. So that's why we still showed you how to do it by hand. Once you draw your line of fit and you want to estimate the y equals mx plus b equation, what is usually filled with numbers in that formula? The m and the b. So you're estimating your slope and your y-intercept. Slope, you need 2 points to estimate. You could try doing rise over run, but with the tick marks and all that other stuff, really you should just use this other formula I showed you. I think that'll be it. And am I providing you this formula tomorrow? No. So you have to memorize it by then. but really it's your change in y divided by your change in x. For that, you need two coordinates that look like they are perfectly on the line that you drew. It could be a data point, but it doesn't have to be. You want to pick something that you don't have to estimate a whole lot. So like the way that I drew it, I'd probably pick this one because it's right in the middle of that grid line. And those values are 6 for the x, 50 for the y. What's another point that I could pick based on the line I drew? And 40. All right. So that one, I see the data point you're talking about on my line. It's not perfectly centered. Granted, if I pick it, it's not going to change my data because it's literally right there. But I just don't want anyone to get in the habit of like, it has to be a data point. It can only be a data point if it touches it and it's like centered on it perfectly. So if you picked 1040, like it really wouldn't change your answer that much. It'd probably still be fine. But there are others that look like they're right perfectly in the grid line. So like this one, which is 845. Right, that one to me on the line I drew looks perfectly centered. This one over here also looks perfectly centered. The 455 it would be, but I only need 2. Okay, so it does not have to be a data point, it just has to be something we don't have to estimate. When you pick your 2 values, make one of them x1, y1, the other one x2, y2, and plug it into your formula. So I'm doing the way I labeled it. 45 minus 50, y2 minus y1, over 8 minus 6, x2 minus x1. You'll notice that the ones that come from the same coordinate are always like right on top of each other in the formula, but of course it's y over y over x. Okay, questions? Because there's lots of variations in this part. However you did it, whatever points you picked, if you did it right, your answer might not be exactly like mine, but it should be close. So class was 45 minus 50. -5, what's 8 minus 6? 2, and probably want it to be a decimal just for this purpose of comparing. That ends up being -2.5. But that's what it is for my slope. Now, some of you did have it done, you know, when I checked it. Is your slope close to -2.5? If it's like -3, -2, somewhere around those numbers, it's probably correct. It just answers vary when we're estimating. All right, so that would give me the M. I still need the B. Unfortunately, I can't see the B, my y-intercept on my graph. If I did, I would just say, make your life easy, estimate where it touches there. Since I can't, I have to do it algebraically. So what I'm going to do is I'm going to plug in the slope that we just picked, or not picked, estimated for the M. And then I'm just going to pick one of the XYs from the line. And my Y would be 45. My X would be 8 if I'm picking that coordinate. Again, there's variations. And then we are solving for B, our y-intercept. So when it's the only variable, then you can actually get a value. So I'm going to do -2.5 times 8. Let's see if my calculator works. Okay, I got 20. No longer, or -20. No longer by that. And then once you multiply that out, we're trying to get the b alone. How would I cancel out that minus 20? We're going to add 20, and whenever we go on one side of the equal sign, the other. And then my y-intercept ends up being 45 plus 20, which is 65. And, you know, you could kind of verify that a little bit. Like, if this line continued, if be like this, do you think that that point would be around 65? Like, does that make sense? It's certainly not like 30. Like, it definitely doesn't look like it's touching there. You know, so just kind of see if your answer makes sense and write it in slope intercept form with our slope and our y-intercept. If this was my answer key, I would just be looking for is your slope and y-intercept opposed. So your y-intercept, maybe when you did the math, it was 60. Maybe it was 67. Maybe it was, I don't know. Just needs to be relatively close to that. Good, questions? Other questions on other parts? Number 7 on the online study guide. Okay. So review the two-way frequency table. And I like this question. Definitely similar to something that'll be on your test. We all are. But this is one of those things that kids think are easy, but it's also easy to make like those little mistakes and get it wrong. So it says, among those that like snowboards, what is the probability that the respondent also does not like skateboards? And notice our answers are percentages. When we talked about percentages, that had to do with relative frequencies, that lesson, I think it was 3.02. And we know, like, to get a percent, we had to have divided something in order to eventually get it to 1%. The hard part is knowing what to divide. So you have to read it carefully. It's not always going to be like, oh, whatever phrase comes first is what you're dividing by. It just depends what the words are. So it says among those that, or if it says given that, or out of the people that, blah, blah, blah. That is what you're dividing by. So among those that like snowboards, so how many people like snowboards? That's what I'm dividing by. So among those that like snowboards, what is the probability that the respondent also does not like skateboards? So out of these people, how many do not like skateboards? So then I'm going to divide that 12 by 27. If someone does it faster than me, I don't think you said 0.1. My numbers aren't exactly that. 12 divided by 27. I'm going to just double check. Okay, so among those that like snowboards, what's the probability that they also do not like skateboards? 12 divided by 27. Yeah, did you say 0.44 or 0.48? Okay, I think it's 0.48. That's right. Gotcha. Okay, so 0.44 repeating, like, yes, it goes on forever. But if I look at my answers, it's rounded to like 2. To get it to be a percent, we're going to multiply it by 100%. And that is how it becomes 44%. 44% is okay. Yeah. Hard part is just knowing what to divide by. So, and that is just reading to see what should be my denominator. Among those that link should be your denominator. Given that, out of those that tells you what you should divide by. All right, questions on that one? Questions on others? Number 2 on this one? Okay. Okay, so students were asked about what their favorite sport was at different ages. The relative frequency table shows the results. Again, that word relative frequency, you know, like it's decimals or percents, if you have decimals. And it's also good when you're looking at relative frequency tables. Sometimes they want you to, when they're making it, divide everything by the grand total or divide it by one of like the column or row totals. This one was made by dividing everything by the grand total. And I know that because it's a 1 right here, because these are all decimals, but they just could have in 1. And that had to be whatever, however many people were surveyed divided by the number. That's the only way to do it. If it was percents, then you know what they divided by, where it's 100%. And so it had to have been the people surveyed in this situation. All right, but anyway, it says which of the following statements are true based on this information. So gotta see which ones are right. The probability that a student likes football, given that the student is between 8 to 10 years of age, is 0.12. So read it carefully. It says, given that, whatever follows the phrase given that is what it's out of. So given that the student is between 8 to 10 years of age, how many students are between 8 to 10 years of age? And that's because it's in relative frequency form. Like they don't tell us how many students in any situation. But the proportions should still be the same because they divided everything by the grand. So still do that. So given that the student is between 8 to 10 years of age, that's 0.35 for my denominator. Your numerator is going to be like, out of these students, what's the probability that they like football? So what needs to go in the numerator? And then when I divide that, that's going to give me that relative frequency. 0.12 divided by 0.35 is 0.34. So far, I'm not going to pick A. And yours might be shuffled, but my A says that it should be 0.12, so I'm not going to. All right, and then do the rest in a similar fashion. The probability that a student is 14 to 16 years old, given that, so again, that phrase tells you what it should be out of, given that the student likes basketball. What's the number for the total students that like basketball? 0.35. And out of those students that like basketball, how many are between the ages 14 to 16? .08. All right, so 14 to 16, given that they like basketball, that's what I'm dividing. 0.08 divided by 0.05. And that is about 0.23, not 0.08. So I've eliminated 2 out of your 4 options. I do want to make sure our other friend gets theirs answered. So try the other 2 yourself and see if you get the answer yourself. That information. Alyssa, was it a different question? Yeah. 6. Number 6 from the one on the. Okay, so Mary was driving home from California. The following graph records her distance from home and time spent driving. Which of the following must be true about the slope and y-intercept? So first of all, it doesn't tell you what should be x and what should be y. So you kind of have to know if we're comparing distance from home and time spent driving, what should go on like your x-axis? Distance or time. And time is almost always on your x-axis. So time spent driving. And then my distance from home is my y-axis. When she's driving home from California, she's the farthest away when it's at the start. Okay, and it decreases until she's home. So then when we're looking at our answer options, the y-intercept is how far she is from home when she starts driving. You guys agree with that? Yes, okay. And it's select all, so definitely pick the one that says what it means in terms of the real situation. That's when she's not driven at all, so her time is 0, but her distance from home should be the greatest at the start. The slope represents how many miles she still has to travel. So slope is typically what over what? And use the variables to kind of help you with that. So my rise is on my y-axis. This is my distance from home over the time spent driving. So when it says the slope represents how many miles she still has to travel, the slope is gonna be negative, so I wouldn't necessarily say that that's how many more she has. That's how much she's traveling for every one increment of time. So I wouldn't say that's how much she has to travel still, because it's what it's changing by. Your slope is your average rate of change. So I wouldn't pick the one that says that that's how many miles she's going to travel. That's just her average rate that she's traveling by. The slope of the line is negative 65. So that you're gonna have to find 2 parts and do rise over run or do that other formula, I think. I'm gonna do rise over run, but my rise going from 300 to 200 is negative 100. My run is from 0 to 2, so you have to pay attention to those tick marks. It says my slope is negative 50, not negative. Okay, so don't pick that one. You pick the one that says slope is negative 50. The y-intercept was 300. Y-intercept would be the constant term in the equation. Do you guys know what constant means? It means like single number, so not the one multiplied by x. Okay, so yes, constant would be your y-intercept. Y-intercept is not 6. Slope represents her average speed. I don't know. I don't know if I like that one. He says, yeah, don't pick it up. Because it's not her average speed, it's how much she's traveling per hour on average. I mean, her slope is negative, so it's not traveling negative 50 miles per hour. All right. So have a good day. See you guys later, some of you.